hi everybody. I'm really excited to see so many people interested in developer experience. And my name is Timo Salm, and I'm a pre-sales specialist for developer experience at VMware, focusing on our internal developer platforms running on Kubernetes and the commercial Spring products. In my session, closing the developer experience gap on your container platforms, I will really first want to introduce the topic, so why there's a need for that and why is there a need for Kubernetes at all. And then I will hands-on show you some of the products that help you to provide a better developer experience on your platforms. If you have a look at the traditional software deployment process, it was really like the illustration you can see here on the slide. So developers, they were assigned to a project and were only responsible for writing the code, the tests, and then after an iteration that usually took months or years, they just put it into an artifact, so in the Java world, for example, a WAR file or a jar file, threw it together with an operational manual and SQL scripts to the operators, and then the operators were responsible for deploying the application, day 2, support, and also bug fixing. As you can see here also in the illustration, for the developers, that in general was a good user experience, for sure. Maybe they would expect a better flexibility and the technologies they could use. Usually it was like, okay, here's the WebSphere, Oracle is your database, but at the end, they don't have to care about infrastructure, deployment, etc. On the operator side, it looked a little bit different. The biggest problem of that approach was related to the business, because it's like with that long iterations, etc., and usually they use the waterfall process, there was a huge risk regarding the application, so how long it takes to get it into production in front of the users. So it usually took some months or years to even get some outcomes or money out of it, and also those huge iterations or not frequent releases, they introduce a lot of risk regarding whether everything still works, bugs, etc. Therefore, nowadays we're using an agile approach, and regarding an agile approach, it's really the goal is to release the software as often as possible and also as soon as possible. And also, because in the past, most applications were built, so one huge team working on a really huge application, complex application. It was like, the operational deployment was relatively easy, and the operators had a lot of time to provision the infrastructure for that because of those long iteration cycles. Nowadays, applications are more built into in microservices to foster, for example, the speed where the application is built as smaller services, and this huge team is split into smaller teams for that. And this operation of that application is a lot more complex, and therefore this approach doesn't work anymore, not only because of the speed, also because of the expertise you need to run those applications. And to get those modern applications into production, you need a lot of collaboration between the developers and the operations, and that's, you may have heard that, a DevOps culture. So DevOps is not a team, it's not people, it's at the end a culture. And this culture is supported or enabled by a lot of automation, because at the end, with automation, you're able to reduce the risk, errors, etc. And also you get a lot more speed than just people like here talking to each other. Regarding automation, we have continuous integration, continuous delivery as technologies, and also containers help, for example, with a rapid application deployment, because the startup time is a lot faster than with VMs, and also for the provisioning. As you know, with Kubernetes, it's really easy to provision a new service, and therefore also gives some speed or developer productivity to the organization. Last but not least, because it's most often misunderstood, with an agile approach, also developers are responsible, development teams, for the full lifecycle of the application. That means that they are not, that doesn't mean that they are responsible for the deployment of the application, etc. That means that they need the tools to support them, identifying whether the application works like it should be, and therefore there's a huge need for observability. As already mentioned, so Kubernetes and containers, they enable a lot of things you need to deploy and run modern applications. with those shortened software development cycles, but they also have a lot of additional value, like, for example, the improved resource utilization to save costs, and especially the fact that it enables a hybrid cloud model makes Kubernetes to the de facto infrastructure abstraction standard. And what's also important to know is that Kubernetes is not a platform, it's a tool to build a platform. And the abstraction, so container as a service, is for most of, so if your organization does individual software development, too low, so the abstraction is too low, and with that you're wasting a lot of time, and also things like security, consolidation, and compliance are a huge problem. Another thing about Kubernetes is really, because as I said, it's a tool to build a platform, it has a really huge ecosystem, which provides a lot of value. But selecting the right solutions for every capability you need in your organization, and finding and also then updating and managing it, installing it, and integrating it is a lot of effort, and that's also the reason a lot of operators, they don't even have the time to care about the developers. But on the other side, it would help them a lot for prioritizing features, for example, with a platform, and also to reduce the risk that developers, for example, go to the public cloud because there they get what they think they need. So it's really about, you should focus on the value you provide with your solutions as an organization, and also frequently ask the users of the platform so that you can prioritize and provide the solutions they need. If you're more interested in the topic and methodologies to do that, you may have heard of platform as a product. Regarding the developer experience gap with container platforms, a lot of organizations I'm talking to, it's like, okay, so they just provide a plain cluster, some basic tools like for ingress, etc., and that's it, because the developers, they ask for the flexibility. Here they get the flexibility. But especially if you are in a huge organization, that's not the right approach, because what's important is security and compliance, and also productivity, because they are wasting a lot of time, and every minute they are focusing or working on infrastructure is missed business value, and at the end also then income for the organization. So developers shouldn't care about that infrastructure. They just need the tools provided by the platform to, at the end, run the applications. And as you can see here, what are developers responsible for example, defining the Docker file, so the container the application runs in. The big benefit of that is the flexibility they get, because they can define whatever base image they want. But at the end, the huge problem is with that, who cares about the security? So which base image? Also the version, the updates, it's all in the hand of the operators. If you compare it to the old times or the traditional software deployment process, I don't think that any operator or organization thought about, okay, let's the developers define the virtual machine image, define which WebSphere version, Oracle, etc. So why are they responsible for that now? And for sure, you can think about it, yeah, but it's all about balanced teams, and we have operators in those teams. From what I see in reality, in most of the cases, that's not the case, so the developers have to do the work. And from what I also saw, it's like, the developers mostly, they update the base image if there's a new Java version available and they can use new features, but they don't care about patch releases. If they have a container image, they still have to define all those YAML files, etc., run it on the Kubernetes cluster, and as you can imagine, it's a lot of work. And it's also like, even if they have the expertise, there are a lot of moving parts. So it's not just like, okay, so I have deployed it, I don't have to care about it anymore. And therefore, all those steps should be abstracted away from them. As you can see here, one of the VIPs of Kubernetes, I would say, just wrote on March on Twitter that in the focus, in the future, it will be really like the developers, they just write their code, define little configurations, so for example, which data services they want to use, and the platform does the rest. So this is really the vision of Kubernetes, I'd say, or this is how it should be used in most of the cases. For sure, if you, for example, get your applications from an ISV and just have to deployment, that's a different story. But if you have individual software development, this is how it should be. And in the next few minutes, I want to show you how you can maybe do that with some of the solutions that are already available now. And this experience, we call it an app-aware platform, and you can really easily see on the abstraction how it is in most of the cases. So you have to build your applications in a way for that infrastructure that begins with Docker files. then all the YAMLs to deploy it, but also things like that your application in a way has to consume config maps for the configuration, etc. And with that also, it hinders the portability of your applications. So with an application-aware platform, the idea is that the developers don't have to care whether the application runs in a container, a VM, or whatever. And yeah, for that, let's start with the first problems developers have to solve. That's the container image or a Docker file. As you maybe know, it's really easy to run an application on Kubernetes. You just search, for example, how can I deploy or Docker file for Spring Boot. That's on the left, 4 lines of code, and your application, you build the container, you push it, you apply it to Kubernetes, maybe with a kubectl create deployment, and it's running. But yeah, as you can see on the right, that's a best practice container image for Spring Boot. It starts with using defining the base image. So it's a different base image. You can also see that it's a multi-stage build, so to reduce the size and also the attack vectors of the container image. Then it's using layered jars. The big benefit of that is that your application code, which frequently change the business codes, is in a different layer than the dependencies. And so if you add your new functionality with the caching functionalities of your container registry and also the runtime, only those layers that changed will be pushed to the container registry and also pulled from the Kubernetes nodes, which helps, as said, with a for example, the disk space also on the Kubernetes nodes, but also on the startup time of your container, and if a new container has to be pulled. And yeah, to solve this problem, Heroku and Pivotal defined the Cloud Native Buildpacks standard, which is also part of the CNCF or contributed to it. And the idea of those build packs is that you have for different capabilities of your application, you have specific build packs that at the end detect whether they can contribute to the container image. Like, for example, if you have a Spring application, you have Maven as a build tool, it detects, oh, it's a POM XML, so I, as a Maven build pack, can contribute to that. What it does then, it runs, for example, Maven package and builds the application. Then there are others, like, for example, for the JRE that contributes, the JRE at the end, for example, certificates, etc. And the idea is that you don't write anything. The build packs detect, I know how the source code has to be built. And that's for sure not only available for Java, and you can also build your own build packs. And yeah, developers don't have to care about the container images. There is a local CLI called Pack CLI, but also, yeah, running it via CLI is maybe nice in a CI/CD, but yeah, it's better to have a solution for that that does all for you already in the Kubernetes cluster, and this is KPack. So currently, we're working on also contributing it to the Buildpacks.io organization, or to then at the end to CNCF. And what it does additionally is not only it builds the containers in the Kubernetes cluster, so there are a lot of more resources available, etc. It also automates the updates of the base image. That means no one has to care about base image updates. It's just like there is a new base image available in the cluster, or also directly fetched from the internet if that's possible. And as soon as that's the case, it will start rebuilding all container images with a new base image, for sure. At the end, you then go through the same path to production as before and validate whether the application is still working, but in most of the cases, there are no changes that really affect the application. So base image updates in the hand of the operators, and developers don't have to define anything about Docker files. Just as an information, if you still have the need on the developer side to say, hey, but our application is so special, there are no build packs available, and we have open source build packs called Paketo for every major languages. There's also Canico, which is a solution originally by Google. It was also part of the Knative project, which builds Docker files or applications with Docker files in Kubernetes clusters as an alternative. So if you have both, you can provide the flexibility to the developers. And here you can see really those different aspects of, for example, KPack. So you have your application source code. You can also define it in a way that it frequently watches the Git repository, and if there are changes, starts creating a container image. In most of the cases, you have a CI/CD pipeline, so you define it as a specific revision. Then you have those build packs that know how to build a source code and put it in a container image, and then you have those base images. And if any of those changes, also the build packs, as said, KPack will start rebuilding a container image and pushing it to a registry. So yeah, let's see this a little bit in action. And for that, what I will do is first create such a configuration for Kpack. Here I will use, just because it's a little bit easier to see or discover, I will use a CLI, which called KP because of Kpack, and run an KP image create command. Create command, the only thing I have to provide here is, okay, here's my Git repository. For sure it's also possible to build from local source code, for example, in a CI/CD pipeline, and the tag I want to push it to. And everything that's required, like, for example, credentials, etc., they are running in the cluster. So it's really like, here's my source code, build my image, and providing to this tag in the registry. What I can have a look at now is those cluster, so how those container images are built. So with the build packs and the stack. And for that, I can run a cluster builder or have a look at a cluster builder that's running in my cluster. You can see those are the high-level build packs, so for different technologies that are used by your developers. As mentioned, there are also others available in the community. So the open source ones from us are called Paketo. And then you can see, if we scroll to the top, you see a lot of modular ones that are packaged into those others. So from Gradle to Maven, certificates, etc. And so everything that you provide as a source code that's implemented those technologies is, can be built with a Kpack at the end then. And you can also see here is the reference to the base images. So in this case, Ubuntu Yummy Shellfish. Yeah, with that, as that, if something changes, it will be updated. Let's now also have a look where the image is already available. Not yet, but we can have a look at the build also. So first, build list. We can see it's still building, and also logs. At the end, it's just a log, so I could also just go to the pod level and have a look at it. And here you can see, so it just finished. And at the beginning, here, this is the detection of those source code. So it's a Spring Boot application. It identified all the build packs that are needed to build a container image. So from Maven to here, that's the JVM or JRE, to Spring Boot build packs that add additional stuff. And then every build pack, just based on an order, does the job. Like, for example, here, building the application with a Maven build pack, and then exporting all the layers and pushing it to a registry. So now we have our container image at our registry. Great. So now we have abstracted away container building from the developers and have the hands of the base image updates in the hand of the operators. So what's the next step? So next, I think I want to deploy the application. And as you know, what I could do is just create a deployment, a service, an ingress, and maybe some other stuff around it, and it would work. But the question is, yeah, why does every developer has to do that job? And there are a lot of things already also that you maybe want to include, like, for example, security context, etc., which you should, in a way, maybe abstract away from the developers. For that, we are looking for a serverless runtime. And let's first define what serverless is. So serverless, you can group it into two parts. The first part is a backend as a service, which is really about replacing server-side self-managed components with off-the-shelf services. Examples are like, for example, instead of implementing and managing your own authorization server, using something like Auth0 and Okta. The second one is function as a service. It's really about a new way of implementing applications as individual functions, and don't care about the server-side stuff around it. And yeah, what's at the end, why are they both called serverless? It's like, because at the end, the focus is really on the business value, and you don't have to care about your own server hosts or processes. A serverless runtime, I think you're all aware of, is AWS Lambda, but unfortunately, that's not available for Kubernetes. For sure, you could integrate it in a way, but doesn't really make too much sense. But yeah, there's Knative, and Knative is a serverless runtime on Kubernetes in addition, so that those capabilities are in the serving project. There are two additional ones. The one is eventing, which is really focused on event-driven serverless applications. So with triggers, defining or abstracting away the brokers, where those events will be sent, etc. And a newer one, which is called functions, which enables developers to easily build and deploy functions. And it's also, they are just adding the functionality to use Cloud Native Buildpacks for this experience. Currently, it's roast to image because the main driver behind that was Red Hat. So let's give it a try. Let's deploy our application. For that, we will also use the CLI. So I will just run kn as the CLI, service create hello world with an image. So for sure, you're able to define more stuff, like, for example, the minimal scale, etc., because it includes auto-scaling capabilities, which you need for serverless applications. And you can see I just say, here's my image, which I built before. And within seconds, I should get an URL. So it's based on the configuration of Knative in the cluster. It's generating my ingress, even as you can see with TLS. So a lot of stuff is abstracted away. We can for sure curl it. And it should respond. And what we can also do is have a look at all the resources that are created by it. So by running the tree command, which is a plugin, I can see what it does for me. For sure, with all the configuration that's in the Knative installation in the cluster, you can see the Knative service, so it's also called a service, but that's the Knative configuration, creates a configuration because it has the capability of revisions. So you can fall back to a previous revision. You can also do blue-green canary deployment, traffic splitting, those capabilities. You can see that it creates a deployment for me, auto-scaling with a configured autoscaler that you have, and then it creates a route with all the ingress configuration. For sure, I can also have a look at the YAML so that you see it. So all those things are for sure Kubernetes native and therefore YAMLs, even if I use the CLI. I can see it's just like this specification is like a typical container. So, or a pod specification, so you can define all the security context stuff, etc. there. What I also want to show, because what's special about it is not like, okay, so they are generating a lot of YAML for me. It's also helping you because at the end it has auto-scaling capabilities. And for that, what I will do first is go to a jump box I have because my computer is not capable of sending so many requests. I run watch on the pods, and you can also see there is no pod for this application because of the default scale to 0. So if I run the curl, you can see it takes some time because the container will be started, so the first instance. And then you can see here it's running or it's starting, so we saw the scale to 0. And now let's execute some commands, some requests to it. That's already enough because you saw it's sending some requests per second here, and you can see how it auto-scales. So in this case, because it's a Spring Boot application without, or not, for example, created as a GraalVM native image, it takes several seconds, but now it's able to handle those requests, and at the end also then will scale them down as soon as there's no need for them anymore. The next thing we want to do is, okay, how do those developers get their application to production? And for that, we usually have a CI/CD pipeline. So there are a lot of CI/CD solutions available, and most of them have the same challenges. The first is that they are synchronous, and they use orchestration. That means there's a single point of failure, and also that this orchestrator has to be, in a way, triggered to run through a path to production in a synchronous way. But as you maybe know, there are solutions that are asynchronous. I just talked about that KPack. It has the capability to automatically rebuild container images if there's a base image update, for example. This only works with such a solution if the orchestrator is aware of an event that will be sent by, for example, KPack. Another problem is that usually with those solutions, every application, so every microservice has a different path to production. For sure, you can create a template, but if you update a template, how all those CI/CD pipelines will be updated, that's usually something really difficult to do. There's no separation of concerns between developers and operators. For sure, maybe you have a separation between CI and CD, but that's something you have to build yourself. And also, in general, the developer experience is lacking. We have a new solution available as open source called Cartographer, which implements a lot of those different aspects. And the first thing is that it's using choreography, so it's asynchronous, which is a natural choice for a workflow engine. So for example, with Kpack, it just gets the updated base image, it will rebuild it, and then sends an event, and all those different steps that are interested in it will be triggered. Reusable CI/CD, the idea is that the path to production will be provided by the platform. The developers just say, here's my source code, I want to automatically bind, for example, to those services. They apply it, and then they have the continuous path to production. And every application is going to the same path. And even, as you can see here, every web application, for example, is going to the same path to production if you have the tools that support it. It works with every Kubernetes native tool, and for example, to integrate tools outside of it, we are leveraging for specific steps, tagged them, so a synchronous way of doing that. Just because of the time, I will show you what that interface looks like, because we talked about separation of concerns. And that's a CRD, and for sure you could, in a way, also abstract it away with a self-service, so a nice UI to do that. But that's the implementation of that interface for developers. They define, okay, so my workload type is, for example, web application. For any web application, I could use this supply chain that I defined. I say, here's my Git repository, and then they have a continuous path production by just applying it to a Kubernetes cluster or doing it, in best case, via GitOps, so a Git push. And then, as you can see, if I'm using my tree command, step by step, all those resources that are in the path to production will be built. So the first one is a Git repository, so I'm using Flux here, source controller, to fetch the source code. And then in a second, you could also see that it starts building my application via Kpack, and then I have Knative for the deployment, so as you can see here. If you want to have more information about that, cartographer.sh is the URL, so have a look. It's really, has a good documentation to understand what's behind it. So that's it about the CI/CD. So what else do developers need? For sure, we have things like service provisioning, etc. There are tools available like Crossplane, but usually they ask for a UI. And for that, so some of you may have heard of Backstage, so it's really popular. And at the end, what Backstage is a framework to build a developer portal, so a UI for developers, to get an insight about all those different things, for sure, on the operations side, but also in applications that are available in their organization. So because it's implementing software nowadays is a lot about integrating internal APIs, and for that, having looked at the documentation, etc., this is what Backstage provides, in addition with a really huge plugin system for all common tools, I'd say, so that you are able to build or provide such a platform for your Kubernetes platform at the end. Just having a look at what's available. So you have a software catalog, which is really for developers about documenting stuff. You have software templates, which is to kickstart, for example, a new application with best practices in mind. You have tech docs, so the developers can define for their teams documentation for the applications. A Kubernetes plugin to get an insight into the applications running for them, and also search. And then you can see there are a lot of plugins available, more to come in the future, so that you have that experience here, like here, where you have everything in one portal integrated, so you can see CI/CD, APIs, etc. And developers don't have to jump between different systems. So that's it for today. You saw some of the tools I recommend to have a look at for your developer experience, but there are a lot more. So you can see this is a selection of the internal developer platform we are providing of open source tools that are really interesting, like, for example, Gripe for CVE scanning, Carvel, those are tools for Kubernetes management, with YTT for templating of YAML files, Flux, I already showed it in a way for GitOps, Crossplane is really, really interesting for service provisioning or provisioning resources out of Kubernetes with the control plane in Kubernetes. Contour, ingress controller of us, and last but not least, I already mentioned also Canico to build applications with Docker files if you still want to do that. And yeah, that's it for today. If you have any further questions, for sure you can ask them now, but you can also just go to our booth, and yeah, I'm happy to have a chat or connect with me via LinkedIn. Thank you very much.